Hi, welcome back to my channel for the elimination video. We just talked about substitution. I know when to use substitution because I've got variables that are isolated. I will have y equals something. In this case, both of them say y equals something. Sometimes you'll see, there's a good example, here's one. Sometimes you will see one variable that is isolated, and then in the other equation, neither variable is isolated. So when you already have y equals something or x equals something, that tells you, okay, I know what x is, I should substitute that value in somewhere else. For elimination, the way that you can identify elimination quickly is that in both equations, you have two variables that are not isolated. So if you have no variables that are isolated, then you know to use elimination. And what you're looking for, or what you want to create if it's not there in an elimination problem, is you want coefficients with opposite or inverse values. So I would want something like -2 and +2, or -25 and +25. In this case, I already have -1 and +1x. And since I already have that, I can eliminate the x's already. X minus x is 0. Add your y's. Combine your other like terms, and we know that y equals 5. Since this is solved for y, I'm not done. I still need to find out what x is. So what I would do is I would substitute this value in for y in one of my two equations. Now I'm not going to do the negative one because there's a negative and I want to avoid any difficult work if I can. I'll substitute it in to the top equations. Let me do this in blue. X plus 3y equals 17, or x plus 15 equals 17, or x equals 2. And once you get that final answer for x, make sure that you write your ordered pair, and that's how you would solve by elimination. On number 2, we can already see that I have nice opposite coefficients. So if you want to, you could practice this, solve this one, and then let me know what you get after you pause the video. So you should get -1, 4 as your final answer. But let's move on to something a little bit more challenging. Something like number 3. What happens when these are not already opposites? How in the world do I get elimination? Well, what you would need to do is, first of all, make sure that your variables are already in the correct order. They're already right on top of one another. Everything's organized well so that you can identify whether or not you need to do that. We also have, let's see, -4x plus 2y equals 6. So these would be my two equations if I got them in the same format. And you can see here that, oh, I didn't think I had opposites, but I really do. But let's say I had something like 8y plus 7 equals 15, and 6y minus 2 equals 11. 2x and 7x. There we go. That's better. Now, what I do? Well, I need opposites. So I'm going to look for numbers, and I'm going to do just the y's for this one because it's the first one. I'm going to look for ways to get opposite coefficients. What multiples, in this case the least common multiple, But what multiples can I make with 8 and 6? So my multiples of 8 are 8, 16, 24, 32. And for 6, it is 6, 12, 18, 24, 30. And I can see that the one that they have in common is 24. So I'm going to try to make 24 and negative 24. That way, these reduce to 0. So I'm going to multiply this by 3 and this by negative 4. And when I do that, I get 24y plus 21x equals 45. And negative 24y plus 8x equals negative 44. And now that I have opposite coefficients, my y's should reduce to 0, and I would be left with 29x equals 1. A strange fraction, I understand, but at least now I can solve this system. And that was made possible by multiplying both equations by different numbers to get opposite coefficients for one variable. You could have done it for x as well. You could have multiplied by 7 and 2, or negative 7 and 2, to get negative 42y plus 14. Actually, let me make that positive 42y minus 14 equals 77, and 16y plus 14x equals 30. And then my x's would reduce to 0 because they have opposite coefficients, and 58y equals 107. So quick recap, how do I identify elimination? No variables are isolated. If you already have opposite coefficients, then you're good to go. You can just eliminate those. But if you don't, what you can do is multiply both equations by different numbers so that you get opposite coefficients.